When I first started learning Python, I was amazed by the for loop. I couldn't understand how did it know what to grab, right? I'd coded in C and I understood that you were iterating an index and then had to use that index to plug into different values you wanted. I'd used Ruby and understood, okay, well, it can do an array. That kind of makes sense to me. But in Python, for loops could even do things like strings. And I had trouble understanding when it was applicable, when it wasn't, and how it worked. And eventually I got used to it, but it didn't totally click for me until I understood how iteration works under the hood in Python. So in this video, what I want to do is explain how that all works. I want to recreate a class that is able to be iterated over so you can see how that's all working, and then show a few other more convenient ways for you to create iterators as well. Before we get started, if you find this video valuable, please hit the like button. I'm new to all this YouTube stuff, and a like really helps the YouTube algorithm get this video in front of other people who might benefit from it. So before we get into building any of these classes for ourselves or doing any of that, let's look at what's happening under the hood when we say for x and y. So we can create a quick example. We know lists are iterable. And for I and x, print I. Right? And this will go through the list and print each of the items one by one. And so what's actually happening when we do that? Well, any list is an instance of the overall class list, right? And so that class lists has a dunder method, dunder iter, that returns an iterable object. So if we look here, we can actually say print iter x, which is just another way. Here, actually, let's get rid of this for now. And we can see that is an iterator object that's coming back. Iter x is just a shorthand that we can do instead of actually calling the method that way. And so let's save that, right? Iter object equals iter x. And what is that object? All it is something that has a dunder next method that can be called on it in the same way that returns the next value and then queues it up to be ready to return the following value after that. So if we look at an example here, we could say print next iter object. And when we do that, it's printing 1. And if we called that again and again, we can see it's printing 1 and then 2 and then 3. And so all this loop is doing is it's first creating that iterable object. Then it's calling next on it over and over. And then at some point, that next is going to return something different. It's going to return an exception called stop iteration. And you can see it called 1, 2, 3, 4, 5, and then it has this stop iteration exception. And when the for loop gets that back, it knows, okay, this is done, and wraps it up at that point. So that's all that's happening when we're saying for I in x print I. An alternative way of saying that would be iter object, and then while true, try element equals next iter object, and return element, except stop iteration, and we want to break. So if here, let's get rid of all these. And you can say if I block this out, right, it was print, not return. Print out. There we go. So it's doing the exact same thing. So this and this are exactly equivalent. Let's comment that out for now. And let's build a class that does this for ourselves, right? We've been relying on the fact that the list class has this dunder iter method and has this next method, or at least that the object has that next method. We can create any class that will do that for ourselves. So let's make one that gets us all the even squares. This obviously is not something we would normally do with a class, but it'll be okay for an example. And we initialize with low and high values, and we can save those as self.low and self.high. And we also want to set a counter, and we'll we'll set that equal to low minus 1. We'll talk about why in a second. Now, the first of these that we talked about is the dunder-iter method, right? So let's create that. And all that does is it returns an object that is iterable. And what that means is it returns an object that has the dunder next method that we'll create in a minute. And so if you wanted to, like in the example of lists, it looks like got a separate object that's created that's iterable. But you don't need to do that. So in this case, we can just say return self. And as long as we put a dunder next method in here as well, then it's just going to return another instance of this class, which has the next method. And so we're totally fine. And then in next, all we want to do is exactly emulate what we did here, which is we want to keep creating the ability to call the next object in the list, the next object in the list, the next object in the list. And when we're done, we want to raise that stop iteration exception. So what we can do is say self.count plus equals 1. This is why I started at low minus 1, because this is going to end in return. We want to start by incrementing the count. So we want to start at 1 below so that it actually starts on low. And then first let's make that exception where we would cut it off. So if self.count is greater than equal to self.high, then we want to raise the stop iteration exception. And then otherwise let's create this loop. So while true, if self.count, and we only want to do squares of even numbers. So let's make that if statement, and we can say return the square. So self.count 2. Then after that, we want to increment the count by 1 within that. And you know what? Actually, now that I'm doing it, I'm realizing we didn't actually need to do that. So that should work totally fine. And if I go in here and say x equals this generator of even squares for numbers between 3 and 16, then we should be able to say for I in x, print I, and we'll have that. Okay, I was wrong. We did need that plus equals 1. Instincts were correct. And the reason why is that if we go down this loop, this while loop is going to go until it gets an even number, right? So if it's an odd number, it's going to increment by 1 and go back. If it's an even number, it's going to return. It's never going to reach this because it returns. And then the next time that next is called, it's going to go back to the top, and we want to be incrementing then as well, so it doesn't just get caught in this loop of 4 is even, return 16, 4 is even, return 16, and do that over and over. So if we call this now, there we go. We've got 16, or 4 squared, 6 squared, 8 squared, 10 squared, 12 squared, 14 squared, and 16 squared. And in fact, we can actually, let's go in here, and we can say from iterator import even squares. And actually, here we can get rid of those for now. And let's play around with what that actually looks like, right? So if we say x equals even squares from 3 to 16, then what's the iter of x? Well, in our case, we said return self, right? So you can see that object, and if we say print x, you can see it's the exact same object. So all we're doing is saying, when you go to create the iterator, don't worry about it. This thing already is an iterator. And then if we do that same thing and we say print next x, it's going to print 16, 36, right? Going through all these exact same things. All it's doing is calling next over and over, and then it hits that stop iteration exception. And then it's done. We could call it as many times as we want. It's not going to do anything. So I hope this makes sense in terms of what is happening when a class has the ability to be iterated through. This is all it's doing, is it's running this pattern. And so the class just needs to have this dunder iter method, this dunder next method, and it's able to work totally fine. Now, this is great if you're already creating a class and you want to build in the ability for it to be iterable. But if you're trying to make a quick iterable, it's a lot of code to do that, right? All we want to do is find even squares. We probably shouldn't need this much code to do that. And this is where generator functions come in. Right? They let us build a function rather than a class and do it in a much shorter, more elegant way. And so rather than creating a class, we can just say define even squares, low, high. And the way generator functions work is that rather than a explicit return value, we use the term yield. And yield is basically saying this is the answer to the dunder next method. This is what would have been returned here, but let's keep this state, let's hold that state until next time you come back, and I'll be able to continue to increment and work from there. So in this case, we can say count, same way as before, equals low minus 1, and then while count is greater than equal to high, if count 2, 0, yield count squared, and then increment count. And what's really cool is you notice in this one we needed to have this explicit stop iteration instruction or exception. In this case, the first time it gets back something that isn't a yield, it knows that it's over, and it cuts things off at that point. So what we can do here is the exact same thing. If we say x equals even squares from 3 to 16, we can do that exact same for I and x, print I, and we can see it gets us the same result. So that's quite a bit less code than this whole class implementation above. Now the third option, if you're really looking to go fast, is generator expressions, right? And these are like list comprehensions, and the syntax is very similar, but rather than creating a list, they create a generator, something that can be iterated over. And this is useful mostly because when you create a generator, you aren't saving all the values in memory, right? You're same as above here. You're basically saving the code or the function or the way that you can get the next value. And then one by one, the program is getting those values rather than with a list where it needs to figure out all the answers in order to save them all first. So for any time where you're working with an extremely large list where you don't want to save it in memory, or even something infinite, an infinite list is gonna cause an error. An infinite generator function is actually totally fine because you can keep calling that function over and over to get the next value. So the other thing is obviously with a function, we can plug in our own custom values. With a generator expression, we're creating the final thing. We're creating the generator. And so if we wanted to create the same thing as above, it's exactly like the list comprehension. We can say x squared for x in range 3 to 16 if x2 equals 0. And that's going to work the exact same way, right? You can see if the function were follow this pattern where it's doing something for a specific range or for some set of values with one if condition, it's really easy to create this generator expression instead. And we can say for I in generator, print I, and you'll see this will create the exact same set of values. So I hope this is helpful both in being able to implement these things for yourself, but for me more for just understanding that when I say for x and y, it's not like there's some magic happening. It's just going through a process of doing something that would be a little more verbose and a little bit more work to do manually, and condensing that down into some syntax that's really easy and intuitive to understand. So if you found this video helpful, please give it a like. Like I said, it helps a lot with the YouTube algorithm. And if you enjoy this kind of content, please subscribe. I'm spending all my time right now learning Python and artificial intelligence and machine learning, and I'm going to be sharing a lot more of the behind the scenes as I go. So if that sounds interesting to you, I hope you come along for the ride.